right? What's a midpoint?
Center.
Center of what?
Center of a line.
It can be a center of a line?
Center of an intersection, center of a cross section, center or
If
something.
lines are infinite, how do you find the center?
You got 1 point to another.
So that's called a
segment. But like.
I know where you're going with it. I was just giving you a hard time.
Okay, notice he's writing in the box, you guys. So in one of the boxes on your progression page, you should be writing all of this information and putting it on the picture.
Yep. So one of the first ones that I always like to start out with is something that's pretty easy that most students get. Because we've done midpoints, we've worked with them. That's nothing crazy at all. And we know if we're given a midpoint, we know that that segment gets cut into two congruent segments, right? Okay. So when we have proofs, then messed up all my stuff. When we have proofs, remember what we're doing. We have statements and reasons. If you're given a midpoint, that means you're telling me that something's a midpoint. Why did you write it down? Because it was given. Okay. Your next step is to do something with it. Well, a midpoint creates two congruent segments. So I would state segment congruent to segment. Oops. And my reason, definition of a midpoint. This looks really weird to you right now because you're probably all thinking, what is he talking about?
Yes, sir. I don't know.
Okay.
What are you talking about?
And this is the way that the proof stuff is going to work is that I don't want to show you the start of one until we get a couple of definitions put together, and then you'll see how it, I hate to use progresses, but how it works itself through. Okay. Now, what you'll see is that I'm trying not to use up a ton of space in my square because I like to make an example. Example. X is midpoint of Y, Z. Okay? And then I've got a little diagram. If X is a midpoint of Y, Z, what are the two segments that are congruent to each other? YX and XZ. So that means I know that those two segments have to be congruent. So what I do then is I make my little example of what it would look like. Move this over just a little bit. So X is midpoint of YZ. This was given. In a proof then, it's telling me I'm given a midpoint, so I have to state that two segments are congruent. Well, what are my two segments that are congruent? YX is congruent, XZ. The reason those two are congruent, because that is the definition of a midpoint. Okay? It looks weird, right? It does. But the idea behind it is so that way we have information of where to start. What's that? Def midpoint, yeah. So I'll write it up here. So X is midpoint YZ. Yeah, some of these will get a little bit small as I'm writing them in there because I've run out of space. So what I'll do is when we have our little example parts, I'll put them on the whiteboard, but you'll just have to fit it in there. Right? Now, the reason why I wanted to show this
You talk about locals really fast.
I know where all the stuff is. Because what'll happen, and obviously this is nothing that we're doing right now. What'll happen, don't write any of this down. what'll happen eventually is that we'll have something that looks like this. M is the midpoint of segment AB. Yes, ma'am. I don't want to run the restaurant's fine. If I'm looking at this picture here, if M is the midpoint of AB, what are the two segments that have to be equal? AM and MB, because that's what that midpoint does. B is the midpoint of MD. Well, that means MB and BD are the same. Well, MB has one tick mark, which means how many tick marks does this get? One. So the idea is that we'll be able to utilize these types of statements to work through to show other bits and pieces. Okay? How we'll be able to switch back and forth. And that takes a little bit of time to get used to. All right? Question on midpoint?
Yeah.
Oh, it's not on there.
Okay.
All right.
Alright, continue.
Let's try another one. Oops. Another one that's very similar to midpoint is segment by segment. Okay.
Yeah.
Yeah. So midpoints and segment bisectors basically do the same thing. One's just a point. A segment bisector can be a line, array, point, anything. But the reasons and the definitions are all kind of similar. So if given segment bisector, we're going to state segment congruent segment. The reason, definition of a segment bisector. Very similar to a midpoint. The only difference between the two is that a midpoint can only be a point. And this, where we did earlier, X is a midpoint. Whereas a segment bisector could be a point, array, a line, another segment. Okay. It could be anything. So the only difference is that. That's the only difference. We still do the same basic principle. It still looks the same. Segment bisector creates two congruent segments and so on. So for example, if I write that out as an example, XY is the segment bisector at AB at point Y. I'm trying to think of an easy one to write it off as best I can. Okay. So I'm running out a little bit of space on that, so I'm going to draw a picture over here and fill in the rest of this part on the whiteboard. Is that okay?
Yes.
So in my head, I'm thinking I have XY as the midpoint, or excuse me, the segment bisector of AB. So here's AB. XY is the bisector at point Y. Bless you. And I can do that. You okay with that? In my head, that's just kind of how I pictured it as I was saying it. It could look any different. It could look anywhere.
It could be array.
Yeah. I dropped it on the sun. Sorry. I dropped them.
I know, when I had my stitches in, did I have my stitches in?
No, you just got them out. You just got them
I
out.
just got my stitches out. I dropped out some papers. But the worst person would probably drop papers off when I just got stitches out and I couldn't move my mouth. Because then he's like making me laugh and being all silly. And I was like squishing my face together so I won't smile and stretch my face. And then he's like, I'm probably the worst person. I'm like, yes, you are.
We got her a get well card.
Everyone comes going, what's this?
I obviously, I didn't have a get well card laying around my house, but I knew that I had a stack of thank you cards. She's already laughing at it. So I grabbed the thank you card. My wife saw it, and she's like, why do you get a thank you card? I'm like, oh, I see a get well card from a store. And she's like, you would get her a thank you card. It says get well. So I crossed off, just put an X across it, and I wrote get well in a pen. But the whole math part is like, yeah, this is something we would do. Anyway, sorry. So here I'm saying that XY is the segment bisector of AB at point Y. According to this diagram then, what would be the two segments that are equal to each other, or that are congruent to each other? AY and YB, good. So what you're doing is, your proofs will have diagrams that accompany them, okay? The proofs will have diagrams that accompany them. Not like the algebra ones where it's just an algebra. You'll have some sort of a picture. I always say, and Ms. Throw always says this as well, mark your diagrams. If I know that this is the segment bisector at this point, I know by definition these two have to be the same. All I need to do now is figure out how do I write that down in terms of my example. Well, in terms of my example here, first thing I would say is XY is the segment bisector of AB at point Y. This is my given. This is the example that I would put in here. I just was running out of space on the smartboard.
So you want us to put on that?
Sometimes if you need to make two boxes out of it, that's fine. I'm just saying that I've got plenty of these. How many did you have total on yours? We have what? 12? We have about 16 or so?
Yeah, like we get the whole first page is full before we do.
Triangles?
Yeah.
Okay, that's what I thought. So, and then, now according to our diagram that we just filled in, AY is congruent to YB. And what do you think my reason is? Because of the definition of a segment bisector.
I can see it again. Thank you.
All right. So the idea is you're going to be given some specific mapping, geometry mapping, if that makes sense. Something that has a definition to it. What we're going to do is we're going to utilize that definition in a manner that helps us with the proof.
Can't I just made a whole different
Yeah. This is your sheet, and it's totally up to you how you want to do it. It is not a big deal however you want to place it, however you want to write it. I'm not going to look at this except for once in a while. I'll say, hey, I want to see how your progression sheets look, and go from there. Okay?
Yeah?
So far, so good?
Yeah, look. Good enough.
It's fine.
You want to do it?
I'm working here. Let's see. The next one we can do that works pretty easily is complementary. All right. So let's do that. Let's say, if given, complementary angles. Yeah, don't do complementary, supplementary, we get paired angles. I think that'll be the
Great, thanks guys.
Bye. I promise not to make you laugh in the next 20 minutes.
Thank you.
Well, already. She's laughing. All right. What do complementary angles do? They equate how many? How many angles are there? Two. So then I know that I can state angle plus angle equals 90. Okay with that? Angle plus angle is 90. What do you think the reason is? Take a wild and crazy guess. Exactly. Definition, complementary angles. This is kind of a reoccurring theme. You're going to be given something that has a definition to be used. That's how proofs work. Whether they are segments, angles, whatever, you'll have some bit of information that has a definition behind it. You just utilize that definition. So, for example, I'll call it angle 1 and angle 2 are complementary. Okay. I'll say that angles 1 and 2 are complementary.
How much you fat?
Angle 1 and angle 2 are complementary. That's given.
Both sides are big, both sides.
Okay? If those two angles are complementary, what do those two angles have to add up to equal? 90. So, angle 1 and angle 2 are complementary.
So, we like to draw that picture.
Bless you. You don't have to, but if you want, that way you remember the complementary means 90, that's fine. Okay. Now, these are the two angles that are given that are complementary, so that means those two have to be the angles that add up to equal 90. So now I know that angle plus angle, well, the two angles would be angle 1 plus the angle 2 has to equal 90. The reason being, definition of complementary angles. I don't know what either one of those angles measure, but I do know for a fact that when you add angle 1 and angle 2, they have to equal 90. That's all I have to worry about.
Wow, it's fine.
Oh yeah, that is true.
Okay?
But it's already in my head.
That's
Good. What'll happen as we get into this stuff, probably, I don't know if we'll get to do any real proof stuff today, but when we get to it definitely on Thursday, you'll see why we use these sheets, because it makes everything so much easier. Okay? Excuse me. We okay with complementary?
Yes.
All right. If we do one with complementary, what's the other one you think we should do? Supplementary. So we'll do one with supplementary. What do you think the only difference is going to be? 180. It's the only difference. Okay. So now, if given supplementary angles. What's up? The heat is on. It's very warm. So, definition of supplementary means you have two angles that add up to equal how much?
180.
180. So, I would state angle plus angle is 180. What do you think my reason is? Take a guess. Definition of complementary. Or supplementary. Maybe say. Definition supplementary angles.
No, I can make it so weird.
It's okay. No, I gave up on that a long time ago.
Like that one there.
I'll survive. Example. Angle X and angle Y, oops. Angle X and angle Y are supplementary.
What they are. What is that? Just like
Angle X, angle Y are supplementary.
why you draw like that?
Draw however you can draw however you want. Okay? So that means then if I fill that in, angle X and angle Y are supplementary. It just told me, I know that I have that given, which means I can say that two angles add up to equal how much? Please. 180. What are the two angles? X and Y. It's literally right in front of you. Angle X plus angle Y is 180. Definition, supplementary angles. What this is going to allow us to be able to do is know how to start. Like I made mention last week when we get into proofs, these progression sheets basically will get you through 85–90% of your proofs if you follow them clearly. The other 15% or so is dependent upon you to be able to mark your diagram correctly and maybe come up with one extra step to show how something works. But if you're able to go through these things and just follow your steps, follow the progression, the last bit is usually pretty easy. Okay. All right. So we had, what do you call it? Complementary, supplementary. Let's do linear pair.
Okay, so you tell me we don't got it.
We might, it depends on how many these you can get through.
Okay, come on.
Okay. Let's do linear pair. Same thing. If given, linear pair. Linear pair creates what? A whole a line, right?
Oh, a straight line.
Are all lines straight?
No, the,
Two adjacent angles whose non-common sides are opposite rays.
Which means they create a line.
There you go.
What do those two angles have to have equal then? 180. So again, if I'm given linear pair, it's kind of the exact same thing as supplementary. Okay? But they're just adjacent. So all we have to do then, if given linear pair, what we're going to do is state angle plus angle is 180. Now I know that this was the same thing we just did for supplementary, but it's okay that they use the same style definition. Kind of like how midpoint and segment bisector were kind of the same. These can also be the same. All right. So in this case, my reason is just definition linear pair. So example-wise, what could just be angles A and B, angle A and angle B are a linear pair. Okay. What's that? I know, right? And the downfall is sometimes with proofs, especially with angles, angles not always are used with just one letter, or angle 1 or angle 2. A lot of times angles have 3 letters, and they can get kind of messy. It's not any more difficult, it's just there's 3 letters that make up an angle. So if I say angles A and B are a linear pair, then the next thing that I can state is that, draw a picture. If I say angles A and B form a linear pair, then what I can go with right away would be that angle A, angle B are a linear pair. There's my given. Then I can state angle A plus angle B is 180. And like we just said, definition, linear pair. All right. What's that? I don't know. So far, so good?
Yes, sir. Wait, but yeah, most there.
It's, so I know it could be, this is kind of tedious, and I know it's probably what you're thinking right now, but you have to trust me that this is going to help you in a few days. Tremendously, okay? I know, it is, It's one of those downfalls. I tried to make, I know that proofs for students, they don't like them very much at all. So what I've tried to do over the past few years is come up with a way to kind of funnel all the questions you guys are going to have throughout all of this and put it all in one sheet. You can use more than one box to fill something out, or it's whatever you want. I try to make it as big as what I thought would be okay. It's a normal spot for it. But if you want to use 2 squares per thing, it's fine. I got plenty of these. It does not mean it has to fit in one spot. All I'm trying to do is get the info for you in one spot for you to find. Okay? That's what I'm trying to do here. Okay? I don't know if we'll do them all today, but. All right. What's that? Yeah, we're cruising. So it's supplementary bisector. This will try to a little easy one I want to throw in here. Let's do angle bisector. Yes. Use your other hand.
I can't. Absolutely.
Okay. If given an angle bisector. Second bisector. Oh. Okay. Guys, stay off the phones, please. Come on. So, just like we had earlier, segment bisector created 2 equal congruent segments. Midpoint created 2 equal congruent segments. What do you think an angle bisector creates? Congruent angles. So, if given an angle bisector, now we're going to state angle congruent to angle. Reason? Definition of an angle bisector. One of the main things that people screw up when they do proofs is that they're just going to write down random things thinking that they're going to figure it out eventually. Well, if you're writing down definition of angle bisector and we're dealing with segments, watch what you're doing. You have all the answers in front of you. It's just a little weird. Okay. So let me draw an example here. Let's say we had A, B, C. We'll say BX. Okay. So I will say for my example, BX, it's a ray, bisects angle ABC. Okay. BX, the ray BX, bisects angle ABC. I would draw this one so that way you can see where the letters are coming from. Okay. I know that I try to fit it all in on one square for you guys to see, but I know that I want to write it big enough so the people in the back can see it, so that's why I've written part of it on the whiteboard as well. So as I'm looking at this, ray BX starts at point B. Well, convenient that B is the vertex of angle ABC because it's the middle letter. Okay? Now, if this is a bisector, I know that in my diagrams that these 2 angles have to be equal to each other. Angle ABX and angle XBC have to be congruent. So, I'm given to raise the angle bisector. The thing that I have to state, angle congruent to angle. Well, what are my congruent angles? Well, I just mark them on here. Now I just have to write them down in terms of letters. So my example then, for my example proof, I put in my given statement, which was, so I'm just a little here, BX bisected angle ABC. That was given. I'm going to state now angle. Well, ABX. Use the lettering. ABX is congruent to angle XBC. The reason is definition, angle, bisector. I'm given information that has some sort of a definition to it, and all I'm doing is using that definition to get to the next step. Okay? I'm given information to work towards. Then,
Yeah, for one? No, because we don't have it down there. Not even one. I think we finished one more. Oh, shit.
so we did. See, that's what I just want to mark off the ones we did that way I don't forget where we're at. Angle bisector, complementary, linear pair, midpoint, segment bisector, supplementary. Okay. All right. We'll hold up here. We'll finish this Thursday and do a couple proofs then Thursday.
Thank you.
It's kind of weird because what'll happen is, like I was saying, we'll be given stuff like this, and we'll have to be able to take this information and switch it from geometry land to algebra land. And it's not any difficult, it's just, you know how to do it, you just gotta, how do you write it sequentially, so this is the weird part. Once you get used to it, then obviously.
Which I can see my